Hey guys, welcome. This is 2.2, factoring quadratics to find their roots and their solutions, the number of solutions. So today students will be able to solve for zeros by factoring. All right, so let's take a look at your bell work. It says to solve, so that means to isolate x. Okay, first of all, you got x on both sides. Let's go ahead and combine them, and to combine them, I'm going to subtract x from both sides. Cancels out, so you have 2x plus 3 is equal to 17. I've discovered that if you combine the x term first, it makes your life a lot easier. Next, subtract 3 from both sides, so now you have 2x is equal to 14. Divide by 2, x is equal to 7. What does that mean? That means when you substitute 7, you're going to get a solution. For example, okay? So here you have 3 times 7 plus 3 is 24, and you should get the same answer on the other side. So 7 plus 17 is 24. So 24 is equal to 24. And that's how you know. All right, now let's go and look at quadratics right here. First of all, this is in standard form, okay? And your C is always going to be your y-intercept in order from highest degree to the lowest degree. Today, you guys are going to learn how to factor from standard form to a factor form. And here's what a factor form looks like right here. Why do you want to do that? Because you can set each of these equal to 0, and you can solve for the x-intercept. Piece of cake. Right, guys? All right, let's see if you guys remember how to do this. And if not, please pay attention. We're going to use this method. Okay, so here's your first one. You have a quadratic. It's in standard form. What you always want to do is factor out your greatest common factor first. So what is your greatest common factor? Let me get a pen of different colors. Okay. So your first thing is, if you look through there, you can factor out a 3. So I'm going to take a 3 out of each one of these. So I'm going to factor out a 3. And when you factor out a 3, you have 2x squared plus 5x minus 12, and I'm going to set it equal to 0. Because f of x, I'm solving for the x-intercept. That's why the y is equal to 0. Okay? Next step, you're going to, that 3 that you have factored out, it's going to come along. Okay? And we're going to factor this part right here. So to factor, I'm going to draw 2 sets of parentheses. And my pen is dying. Next, all right. Factors of this 2 will come into play a little bit. Factors of x squared is x and x. Multiply your 2 times your 12, negative 12. 2 times negative 12 is negative 24. You see how that's negative? You're going to subtract, okay? So you want to find 2 numbers that multiply to give negative 24, and it's going to subtract to get you a positive 5x. So the 2 numbers will be 3 and 8. See it right there? So there's your 3, there's your 8. And you want a positive 5, so the 8 will be a 5 and the 3 will be a negative. Negative 3 times 8 is negative 24. Negative 3 plus 8 is positive 5. And that's how you do that. Now, you guys remember the part where I said that 2, your a is a 2, is going to come into play? Remember this 2? We're going to divide each of your constant by 2, just like that, okay? And when you do that, you're going to bring down your 3. Now, 3 divided by 2 is not a whole number. It is a fraction. So the bottom is going to come up. So now you have 2x minus 3. All right. X, what's 8 divided by 2? X is plus 4. And that's how you get it equal to 0. So see how that works? If I were to multiply these out, I am going to get this answer right here. Okay? So let me show you how you would multiply that out. 3 times 2, you're going to have 6x minus 9 times x plus 4. I'm just showing you, show work, how you can check. Okay? This is just how to check. That's all this is. This is for check. 6x times x. 6x squared, 6x times 4, positive 24x, negative 9 times x, negative 9x, negative 9 times 4, negative 36. combine your like terms, and that's how you end up with that. You see it? So now we're going in reverse, and the reverse is factoring. So why are we wanting to do this? Because we want to solve where it crosses the x-axis. 3 equal to 0. Is 3 ever equal to 0? Nope, so you ignore that one. 2x minus 3, set that equal to 0. Solve, divide, and your solution comes out to be 3 over 2. Set also the other factor form equal to 0. Minus 4, so your other solution is negative 4. All right, what does this mean on a graph? Well, let's take a look on the graph. Here's your x and y graph. 3 halves, that's like 1.5. And negative 4, 1, 2, 3, 4. There's your negative 4. See it? 6, positive number, okay? Negative 36, down here somewhere. You're going to have a graph, a parabola that looks like that, and that point right here is 0, negative 36. This one is 1.5 and 0, and this is negative 4 and 0. So there's your x-intercept. That's why you're doing it. That's your zeros. So another word for zeros is the same as the word root, is the same as the word x-intercept. All these 3 words means the same thing. Okay? All right, let's go ahead and do another one. Here we go. How about this one? Okay, let's try this one. Oh, a permanent marker. That would not be cool, right? All right, let's look at this. Here we go. Any greatest common factor to factor out? Nope. So I'm going to go ahead and draw my 2 sets of parentheses. Set that equal to 0. Okay? Here we go. That 3 is going to come into play later. Factors of x squared. X and x. And this method is called bottoms-up method. 3 times 5 is positive 15. See how that's positive? We're going to add 2 numbers, and we want them to add to get a positive 8x. That's your b. That's your middle term. So what are those numbers? 3 and 5. So 3 times 5 is 15. 3 plus 5 is 8. So plus 3 plus 5. Remember that 3? Divide each of these by 3. Okay? All right. Let's go ahead and simplify. X plus 3 divided by 3 is x plus 1, a whole number. Do you see how 5 divided by 3 is not a whole number? So the bottom comes up. So you have 3x plus 5. Set that equal to 0. Set this one equal to 0. X is equal to negative 1. Set this one equal to 0. Subtract 5. Divide by 3. So how many x-intercept is it going to have? 2 x-intercept. Just like that. Okay? All right. Next one. Here we go. Let's try to find this one. This one is not in standard form. So guess what you're going to have to do? We're going to have to move the constant over. So now you have x squared plus 9x plus 20 is equal to 0. Okay. Now, let's take a look at this one. 2 sets of parentheses. Okay, factors of x squared. That number is a 1, so you don't have to worry about that one. X and x. 2 numbers that multiply. 1 times 20 is 20. 2 numbers going to multiply to give you 20 is going to add to give you 9. That's 4 and 5. Plus 4 plus 5. Divide each of those by that 1. But do you really have to do those? No. Because anything divided by 1 is itself. Right? Set this one equal to 0. So x is equal to negative 4. 2 real solutions. X plus 5 is equal to 0. X is equal to negative 5. Just like that. Okay? So you want 2 numbers. A times C is going to multiply. And then you want them to add. So it's doing 2 things to get that B, the middle term. All right. Let's go ahead and move on to the next one. Here we go. Okay. This one is also not in factor form, so guess what you got to do? I'm going to subtract 9r, subtract 9r. Put them in standard form. 14r squared minus 29r minus 15, set that equal to 0. Just like that. All right. Any greatest common factor I can factor out. I know nothing that goes into 29 because it's a prime number. Okay? So I'm just going to leave it. Draw two sets of parentheses. That 14, we're going to come back later. Factors of r squared, r and r. All right, I'm going to go to my handy calculator. Okay? So 14 times negative 15 is negative 210. And I want two numbers that is going to multiply to get you negative 210, and I'm going to subtract to get negative 9r. So if you get stuck, this is what you can do. Watch how I showed you on the calculator, okay? Go to y equal. Let me clear a lot of stuff that my kid was doing. Here we go. And all you have to do is type 210, okay, you could even do negative 210, divided by x. Here's the x, divided by x. And go to your table. Start at 0. Do you see any two numbers that is going to subtract, every one of these multiply to give you 210, that's going to subtract to give you negative 29. So that would be 6 and 35. 35 be negative, 6 would be positive. You see how we just did that? Okay. 6 times negative 35 is negative 210. 6 minus 35 is 29. So plus 6 minus 39. All right. See that 14? We're going to simplify the 14. Okay? Bear with me. So far, so good? All right. So this comes out to be r plus, divided by 2, 3 over 7. R plus, what is 35 divided by 14? Math, enter, enter. It is 5 over 2. Neither one of these are whole numbers. So the bottoms up, here's our bottoms up. 7 comes up, so 7r plus 3. Okay. Bring up your 2. 2r plus 5. And there you have factor. All right, but that's not what we're doing, are we? It says to do what? Solve. So we got to set each one of these equal to 0. Here we go. 7r plus 3 equals 0. Subtract 3. Divide by 7. Okay, next one. 2r plus 5 set equal to 0. 2r equals negative 5. Divide by 2, so negative 5 over 2. No decimals. Exact answers, please. And there you have your quadratic. Okay? All right, let's do some more. Now let's take a look at this one. Wow, this one doesn't even have a b at all. So another way you can write this is x squared plus 0x minus 9 equal to 0. All right. By the way, these are called differences of perfect squares. Okay? And I'll show you why. To factor, two sets of parentheses, factors of x squared, x and x. Two numbers that's going to multiply to give you negative 9, and it's going to subtract to give you 0. Negative 3, positive 3. Perfect squares. Minus 3 plus 3. X is equal to positive 3. If you set them equal to 0, x is equal to negative 3. All right. That's one way to do it, but here's another way. You can solve using a square root. That's what you guys learned earlier. Okay? So how would you go about doing this? This is like 2.1. So x squared minus 9, add 9, take a square root, and when you square root, you have two answers, and the square root of 9 is positive 3 and negative 3. Same answer. Did you guys see that? Two different methods. The choice is yours. Okay? All right, let's go look at this one. Now, that square root of 9 is 3. That made it easy. Next example, it's not always so easy, okay? Exact solutions only. So x squared minus 50, and I don't care which method you use. What do you think would be the easiest method? Probably square root, because how many terms you have? 1, 2. All right, that's what I'm going to do. X squared, add 50. Square root of 50. What's a square root of 50 the same thing as? Well, that's 25 times 2, right? What's the square root of 25? Positive 5 going to come out, and the 2 has to stay home. Okay? There's your two solutions. One's positive, one's negative. You can write it together like I have, or you can separate them like down here. The choice is yours. Together, separate. It doesn't matter. Polybike 5.1. Okay, here we go. Now let's take a look at this one. This one says find the roots. That's finding the zeros of a polynomial. Why is not this a quadratic? Because it's x to the 4th. It's not x squared. All right, so let me get started. So what do I have? Let me see, make sure you guys can see this. Okay, here we go. 9n to the 4th minus 29n cubed plus 6n squared. I'm going to set it equal to 0. All right. What do they have in common? What is the greatest common factor they have? N squared. All right. So you now have 9n squared minus 29n plus 6 is equal to 0. Everyone good? All right. Now we're going to factor this part. N squared comes down. Draw two sets of parentheses. That 9 will come to play later. This 9 right here. Okay? Here we go. Factors of n squared. N and n. 9 times 6, positive 54. I need two numbers that multiply to give you 54, and it's going to add to give you 29. And if you don't know, go to y equal 54 divided by x. Second table, start at 0. Where do you see two numbers that add to give you 29? 2 and 27. Add. Positive. Add. Plus 2 plus 27. Okay. Now, you remember this 9? Divide each of those by 9. So I can do bottoms up. Okay? So now what do you have? N squared. N. Oh, can't simplify, so 9n plus 2. That comes out to be 3, so n plus 3 equal to 0. Solve for each one. By the way, how many answers should you have when you finish? You should have 4. It can be real or it can be imaginary. Okay? So let's take a look at this one. N squared equals to 0, so n is equal to 0. But do you see how it occurs twice? That's a multiplicity of 2. Why 2? Because it occurs twice. Next one, 9n plus 2 equal to 0. 9n equals negative 2. N equals negative 2 over 9. 2 answers, 3 answers. And how many did I say you're supposed to have? 4. So n is equal to 3. 1, 2, 3, 4. So if there's more than one, you need to write the multiplicity. Okay? All right. Now, next one, I want you guys to take a look. What do you have in front of you? Looks like I got a perfect square and I got a perfect square. What's that a perfect square of? 2x. What's that a perfect square of? 3 squared. What is 2x times 3? 6. Do you see how that doubles? So just something, I'm not going to show you how to do it that way, but I just want you to look, because you could actually see yourself finding a shortcut, okay? All right, here we go. Nothing to factor out, 2 sets of parentheses. Set it equal to 0. That 4 is going to come back to play. Factors of x squared, x, and x. 9 times 4 is positive 36, and you want to multiply that to give you positive 12. Okay, what two numbers? 6 and 6. It's always going to be the same. Just I'll let you know, when you have a perfect square, when you multiply them, it doubles. Plus 6, divide each of those by 4. So x plus 3 over 2. X plus 3 over 2. Not a whole number. Bottoms up, bottoms up. It's always going to look the same. So 2x plus 3 times 2x plus 3. Hey, look at what that looks like. Equal to 0. All right. Since they're the same, I can go 2x plus 3. Since there's two of them, I can write it as a square. Now to solve, 2x plus 3. Subtract 3, divide by 2. Oh, wait. How many answers am I going to have? Square. So that is a multiplicity of 2. So make sure you say that, okay? Oops, sorry. Multiplicity of 2. All right, guys. Good job. Perfect square, perfect squares. There we go. All right. Now let's take a look at this one. That one had 3 terms. How many terms do you have this one? 1, 2, 3, 4. Are they in the correct order? Well, yes. So you're not going to be able to draw sets of parentheses, okay? This method, if there's 4 terms, you're going to do it by grouping. Now, does grouping work every single time? And the answer to that question is no. But you need to take a shot. Grouping means this. Standard form. You group the first 2, you group the last 2. Okay? First 2, you're going to use greatest common factor. What do they have in common? 5x squared. When you factor out 5x squared from this one, you have x. And the other one you have minus 5. You see this plus? Keep the plus. What do these two have in common? A 1. You need to write that 1. And what do you have? X minus 5 equal to 0. All right. Do you see how those two are the same? You write them together. You group them together. Group here. You see how these two are not the same? Times. Group those together. Just like that. Okay? Now solve. X minus 5 equal to 0. X is equal to 5. 5x squared plus 1 equal to 0. By the way, how many answers am I going to have when I finish? Highest degrees of 3, you should have 3. 5x squared equals negative 1. X squared equals negative 1 over 5. X is plus or minus square root of 1 over 5. Ah, look at that. Oh, negative. I forgot the negative. All right. Guess what the negative is going to come out as? You can do it now, you can do it later. But you've got to rationalize, right? Okay. So when you rationalize, I'm going to continue up here. You got x equals plus or minus square root of negative 5 over square root of 5 times the square root of 5 is just 5. See that negative? Plus or minus square root of 5 over 5. So how many answers are you going to have? 3. 1, 2, 3. Take a look. How many real answers do you have? 1 real, 2 imaginary. So how many times is it going to cross the x-axis? Just once. Let's double check. I'm curious. Why not? Okay, watch. 5x raised to the third minus 25x squared plus x minus 5. Graph. Oops. Somebody messed with my graph. Give me a moment. Zoom standard. Do you see it right there? It crosses at 5, but not right there. So let me zoom in real quick, change the window to negative 20, 5, going up by 3. Y maximum's good. Wait a minute. Okay, hang on. I got it wrong. Negative 5. Oh, let's make this a 10. Move it over. Going up by 2. Now your y, I'm going to do negative 20. Your y max, I can do 5. Graph. Basically, I'm just moving the graph over. See how it just does this? There's your I. There's your 2i. Okay? And then there's the 5. Okay, that might mess you up if I just, let's do this by 1. There we go. That way you guys can kind of count. All right. See it right there? Yeah. There's your I, and there's your real answer. So this is real, and this one is imaginary. All right, not too bad, right? Okay, next part. Let's look at this one. Find the roots of the what? Cubic function. This was also a cubic function. Why is it cubic? It's x to the third. In this case, it's r to the third. Count your terms. 1, 2, 3, 4. All right, here we go. Group the first two, group the last two, okay? What do those two have in common? Well, I believe 3 goes into both of them, so 3r squared. When you factor that out, 24 divided by 3 is 8 with r left over. Negative 15 divided by 3 is negative 15. No r. Keep that sign. What do these guys have in common? 7 goes into both. So 8r minus 15. Okay? Something's not right. That shouldn't be 15. That should be 5. I messed up. I can't add. Just kidding. This is not 15. This is not 15. I jumped to conclusion. Negative 15 divided by 3 is 5. Negative 35 divided by 7 is 5. There we go. I don't know what I was doing. Look exactly the same. Group them together. Look exactly different. Put them together. See that multiplication sign? Set it equal to 0. Here we go. 8r minus 5 equal to 0. 8r equals 5. R equals 5 over 8. Exact answer, please. 3r squared plus 7 equals 0. 3r squared equals negative 7. R squared is equal to negative 7 over 3. R is plus or minus square root of negative 7 over 3. Rationalize. Just like that. All right. Continue. R equals plus or minus square root of negative 21 over 3. R is plus or minus I, square root of 21 over 3. There's not a perfect square in 21. So there's my answer. 1 real, 2 not real. Okay? There we go. All right. Now let's look at an application problem. Here we go. An object is launched from a platform. Its height in meters, its second of law is modeled by the following. How many seconds after launch will the object hit the ground? So basically, you have a picture here. The object is thrown, okay? It's at negative 9, so down here, and it wants to know when it lands here. So all you have to do is, this is the x-intercept, right? So we got to solve for the x-intercept, which is your zeros. I'm going to make that into a 0. X squared minus 8x minus 9. I'm going to try to factor. Factors of x squared, x and x. Two numbers are multiplied to give you negative 9, and it's going to subtract to give you negative 8. How about positive 1, negative 9? Okay, here we go. So x plus 1 equal to 0, x is equal to negative 1. All right. This one, x minus 9 equal to 0, x is equal to 9. Okay, so if you're throwing something on the ground, x is the time, so this is your time, this is your height, right? Can you technically have a negative 1? Can you throw something before you actually throw? No, so that's not the answer. So x is equal to how long? How many seconds? So 9 seconds. Don't forget your units, okay? And there you have your solutions. All right. Oh, let me clear it real quick. And there you have your assignment. Got it? Okay, I'll tell you the due date in class. Bye.